Okay, here we are. Shh. We are recording. We do not have technical difficulties today. Yay for that. Okay, that means for you that we are recording live on camera right now. So, here we go. This is the last section before you all have a group test tomorrow. So, yes, inverse relations. So, here is the overall concept and theme of today. Switching x and y. That's all inverse relations are. The inverse, think of inverse as opposite. Opposite meaning you flip-flop x and y. Okay? So, I'm going to write some key things about these down. And actually, pre-calculus is doing some things with inverse relations right now. Something that carries over into pre-calculus and calculus. Okay, so inverse relations or functions, it can be either or, are when x and y are switched. Okay, so let's see. Does that make sense to people if I say flip-flop at x and y? I'm just going to elaborate, but I feel like it's kind of self-explanatory. Okay. Now, so we do have some things that we want to note about that. Inverse functions or inverse relations, they are symmetrical about the line y equals x. Can somebody remind me what symmetry is? So if objects are symmetrical or something is symmetrical. Marcy?
It means if you flip it, then it's still the same shape.
Okay, so if you flip
like,
it, it's still the same.
If
so
you fold something in half, then
okay,
it like it's even, so then it like folds perfectly. Okay, can I just like give an example?
Yes, give an example.
Okay, so like a square is even on all sides.
Okay.
So if you fold it in half, it'll fit perfectly in half. But if you fold like a triangle from like bottom to top, it doesn't fit because it's not symmetrical.
Okay, excellent. Everybody give it up for Marcy. Yay. Jade.
What is SYNN?
Symmetrical. Symmetrical. Okay, so can anybody think of any real-life objects? I know you guys are kind of gravitating towards geometric objects, but not math-related necessarily. Can anybody think a shirt? Okay, so if we're looking at my shirt, where, sort of.
Yeah.
How is this, okay, good. So I see Kendra going like this. That means that if I were to draw a line right here, I could fold my shirt on itself, and aside from the pocket, it would be symmetrical. What else? Anything else? Riley?
A butterfly.
A butterfly? Good. Haley?
Fold a butterfly?
Okay, everybody's in it. It is raining today, and rain makes everybody crazy, I think. So we're all bouncing off of the walls right now. Okay, do you guys need like a minute to just get up and go crazy so that you're more focused? Yes? Okay. All right. 1 minute. Go. Do whatever you need to do.
Stop, Nathan.
All right.
No, that's Ellie's hat.
It's not respect.
Oh, Chaz, I brought some.
All right. 1 minute is up. Now we are focused. That was interesting. Okay, so here we go. Interesting or boring, as I'm told. Well, you all did not use that up very well. Okay, so here we go. The line y equals x. The line y equals x looks like this, okay? Shh. Nobody should be talking. Everybody should be focused. Do I need to get demerits out?
Yes. I have a
Okay, shh. So, a line, if something that is symmetrical about the line y equals x, I'm going to put an object in here, okay? And I want you guys to mimic it as best you can. Let's say I have a curve. Let's say it looks like that. Okay, so if this is symmetrical about the line y equals x, what that means for us is I should be able to take this curve and flip it over and have it like flipped or mirrored on the other side, right? Okay, so that should look something like this. Okay, so if you imagine, if we tilt, let me tilt it this way so that that's straight up and down. It's sort of mirrored, right, over here to over there. Did we see that? Okay, so that's what inverse functions or relations are. They are symmetrical about the line y equals x. The last piece piece that we want to focus on here is the way to denote inverse functions. Gentlemen, are you focusing? Okay. So the notation for inverse functions is f with a -1 as the exponent and x. Okay, so f -1 of x, that's the way we say inverse. So anytime you see an exponent of -1 on functions, that is inverse function. So that should be a key to you that x and y have been flip-flopped in some way. So f -1 of x and f of x are inverses of each other. Okay, Lydia, go ahead.
Is this like, you know how we do perpendicular lines?
Yes.
Because it's like
Yes.
okay.
Yep, good. Very good. All right, questions on this? Today is super easy. Let's go to some examples. Whoop, you needed that? All right, so here you are. Super hyper. Holy cow. Did you guys eat a bunch of sugar before you came in here today?
I don't eat sugar.
Caffeine? Red Bulls? What's up?
I think it's best because now we've all woken up. What? Yeah.
Lucky me. Okay, here we go. Write the inverse of each function. Everybody zip it. Write the inverse of each function and then indicate whether the inverse is a function or not. So we just said that inverse functions, all you are doing is literally flip-flopping x and y. So if that's x and that's y, we flip-flop them for every single coordinate here. So can somebody tell me, we have, let's see, 5 coordinates. Can somebody tell me what the inverse coordinates are? Again, we just said that inverse means you flip-flop x and y. So can someone tell me, Jared?
-2. Wait, which ones are we starting?
Starting with this.
Oh, 1, 1,
Good.
0, 2,
Perfect.
-1, 3,
Uh-huh.
-2, 4,
Good.
-3, 5.
-3, 5. All right, everybody give it up for Jared. That was the worst enthusiasm ever. Okay. Does that make sense to people? All we did was flip-flop x and y. Now, how do we figure out whether this is a function or not? Anybody remember? Okay. Ashley, Garcia. Domain, good. We have domain and range. Excellent. So what about the domain and range? Kendra?
If one of them points to 2, then it would be not.
If one of them does what?
If one of them goes to the same,
She's talking about the domain.
Oh, okay. So if there are repeating x's or domain values but different y's, then we do not have a function. So what you should be, okay, so what I want you guys to be doing in your heads right now is thinking about how you would graph each of these points. If we have any points that are directly on top of each other, we do not have a function. Okay, so if we look at this, to get to 1, 1, we go right 1, up 1. And then we go up 2. And then left 1, up 3. So any of these should not be directly on top of each other. So you guys tell me, is this a function or not?
Yes.
Yes. Good. Why?
Because none of the first numbers repeat.
Good. None of the first numbers repeat. Everybody give it up for Lydia and Kendra and Ashley. Yay. All right. Next one. So, next one. Shh, Lydia. Shh, quiet. Next. Somebody tell me what the inverse of this next one is. Ashley Garcia. Good? Good? That's -3, 12. Good? And the last one is 4, 5. Excellent. All right, everybody give it up for Ashley. Everybody give it up for Ashley.
Missing a parentheses. Or is one parentheses.
They're all there.
on the 4 and 5.
Oh, here. Thank you. Okay, go ahead and give her a point for that. Okay, so now you guys tell me, Jade, is this function yes or no? Why not? Good. Excellent. 6 repeats, but they have different y values. Everybody give it up for Jade. Yes.
So you don't take it from the first to figure out the function, you take it from the inverse.
Yes, correct. Questions? All right, next. Write the equation that defines the inverse. The the equation that defines the inverse of each function. And the first one that we're doing is y equals x plus 7. So what did we just say about inverse? What did we do with x and y? Switch them. So I'm literally going to take x and y and switch them. So I get x equals y plus 7. And then, how do I get y by itself? Who can tell me with a, let's do with a hand, with a quiet hand. Who can tell me, Marcy? Good. Minus 7. Everybody give it up for Marcy. Y equals x minus 7. That's the inverse. Now, if I want to go through and actually put inverse notation on this, I can do that. I don't need to necessarily, but if I were going to put in this in inverse notation, I would replace the y with f negative 1 of x equals x minus 7. Those two mean the same thing. Okay, just one is in inverse notation, the other one is not. Okay? Questions on that? Okay.
So why does it have
The minus 1. Oh,
Yeah.
just like this symbol means square root, that symbol, an exponent of negative 1, means inverse. Okay, other questions? All right, now, somebody walk me through, what is the first step in this next one if I want to find the inverse of y equals 5x plus 6? Rachel. Excellent. Everybody give it up for Rachel. Good. All right, now what? So who can tell me the next step? Josephine. Minus 6. Kendra, did you say that last names are easier?
Yes.
Okay, so Lumaquin. So x minus 6 equals 5y. Do you want to continue, or do you want me to get someone else? It's up to you. Go ahead. That's true. So 5y equals x minus 6. If the last step is to get the y complete, that's good. Divided by 5. Everybody give it up for Lumaquin. So the inverse of this one is y equals 1/5 x minus 6/5. All right.
What?
Questions? What's up?
Why does it have to be white?
As opposed to... Oh, you mean why do we not just leave it right here?
Yes.
Just you want, because the goal is always to get y by itself. Where you're going with this is we're going to actually, in a little bit, graph these. So to graph them, we have to get y by itself. Lydia?
Find the inverse of just a negative x when you just turn positive.
No, you don't do anything with signs of anything. You literally just flip-flop x and y. And if there ends up being a minus in the other one, then that's the way that the inverse function works. Where are you looking? Oh, in the homework? Okay, we'll get to that in a little bit, okay? Okay, if I want to put this in inverse function notation, what would be the very last step? Again, it's not necessary, but Michael?
Would be add negative 1 of x.
Good.
Equals 1/5.
Excellent. Everybody give it up for Own. 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 Thank you. Okay. Kendra.
Say for Lydia's question if it was y equals negative x.
So to find the inverse of y equals negative x, you just flip-flop these again. So x equals negative y, and then divide by negative 1 on both sides. So y equals negative x. Sometimes you'll get the same inverse.
Oh, that, okay.
Okay, any other questions? Here we go. You are all loving this, aren't you?
Why?
Here we go. All right. Next, we're almost done. This is the second to last page, and then we're going to graph.
Oh my. These are some long notes.
Why?
It's funny. We have been going for 14 minutes and 29 seconds, and everybody's like, this is the longest set of notes ever.
Judging that we've done a notes that's like 5 minutes long.
Yes, sometimes it takes a little more
That's
than
like
that.
triple that.
But you guys are saying, is it difficult stuff or is it just long?
It's just long.
Okay, well then, no complaining allowed. All right, here we go. Y equals 2x plus 3 and y equals 1/2 x plus 3. Gentlemen, shh. So on this one, it's saying determine whether the following pairs of functions are inverses of each other. So we want to figure out are y equals 2x plus 3 and y equals 1/2 x plus 3 inverses. So does anyone have any suggestions about how we might be able to figure that out? Marcy, Maxie?
If we switch out the y, and then if they come to opposite answers, or would they be the same answer?
Should be the same, exactly.
The same.
Good, everybody give it up for Maxie. Cool. All right, so what she said is we want to take one of the equations, find the inverse of it, and then compare it to the other equation that we were given. That way, if it's the same equation, we do have inverses. If it's not, then we don't. So this becomes x equals 2y plus 3. Whoops. And then how do we get y by itself? Somebody walk me through the steps. Shh. Akashneet Ram.
You could subtract 3.
Uh-huh. So x minus 3 equals 2y. Excellent. Who can tell me what the last step is? Garcia. That's good. Divide by 2. So we get y equals 1/2 x minus 3/2. So you guys tell me, now that we have this, we want to compare this to the other one that we were given. And are they the same?
No.
No. So are they inverses of each other? No. All right, questions? Pretty easy?
Yeah.
Okay. So then, if it's so easy, somebody walk me through the next one.
I'll do it.
Okay. Johnson.
So you already have that up.
Yep.
And then I was just thinking, you switch y and x, so you get x equals 5y plus 4.
Excellent. Okay. Do you want to keep going, or it's up to you? Okay, go ahead.
Subtract 4.
Uh-huh.
And then and then divide by 5.
Good. Divide everything by 5, so we get y equals 1/5 x minus 4/5. And then, everybody give it up for Johnson. Okay, very good job. We are comparing this to the other equation that we were originally given, and you guys tell me, are those the same?
Yes.
So are they inverses?
Yes.
Yes.
Yeah.
All right, questions?
No.
Okay. Are you ready to be done, Johnson? We are almost there. Okay. You all still using this, or can I move it?
You can move it.
I can move it. They cannot get me off of nodes quick enough here. Okay. Graph each function f and its inverse f-1 on the same coordinate axes. All right. So this is actually really, really, really easy. You all are really good at graphing, right?
Yeah. No, we're not.
Well, you are now. And if you're not, then you will be. Okay, so here we go. F of x equals 3x minus 4. That is the same thing as y equals 3x minus 4. So if I want to find y equals 3x minus 4, the inverse of that, how do I do that? Same thing we've been doing all notes. What do I do? Do what?
You switch them.
Switch x and y. Okay, good. Is this getting a little redundant for all of you yet?
A little bit.
I can always count on you for the truth. Okay. Now, what do I do next if I want to get y by itself? Ashley, Rosander.
Add 4 to each side.
Good. Add 4. So I'm going to switch it around. 3y equals x plus 4. And then, Rosander, what's the last step?
Now you divide by 3.
Excellent. Divide by 3. So I get y equals 1/3 x plus 4/3. Okay. So we are graphing these two lines on the same graph. So everybody draw a graph. And if you all do not need to go through the last one, then we do not have to.
I mean,
All right. So can somebody walk me through graphing? This is, again, y equals 3x minus 4. Y equals 3x minus 4. Let's do this one in blue. And we'll do the other one in red. Okay, so how do I graph y equals 3x minus 4? Favorite shape? Rosander?
Okay, you on the y-axis, you go down.
Good. Down 1, 2, 3, 4. Okay, and then what from there?
And now you go up 3 and to the right 1.
Good. Up 1, 2, 3, right 1. And I'm going to keep going up just so that we get a really good line. Okay, everybody give it up for Rosander.
Wait, I thought
What's up?
So if you have a fraction in your favorite shape box,
Everybody zip it.
if you have a fraction in your favorite shape box,
Yep.
you can just take the numerator and it would be the same.
Not quite. Okay, so we will actually want to, that's a really good question. So in this one, this is red or orangish. Okay, so this is the one case where I would say you probably want to write 4/3 as a mixed number or a decimal so that you get a better idea of where that falls on the graph. So 4/3 as a mixed number or decimal is what?
1 and 1/3.
1 and 1/3. So we go up to 1 and about 1/3. That's our first point. And then from there, the slope is 1/3. So if we start out in between the grid lines here, we want to be still in between the grid lines when we go to the next point. Okay, so we go up 1 and right 1, 2, 3. Up 1 and right 1, 2, 3. We can keep going and keep going and keep going. Okay, so then we connect those. Does that make sense to everybody? Yes. Good. So, that's what our graph should look like. Sorry about that. I'm going to put this in here so you all can see. Remember, that it's supposed to be symmetrical about the line y equals x. Y equals x, so it has a y-intercept of 0, and you go up 1, right 1. I'm only putting this in here so you all can see that it is symmetrical. You don't have to do this on your homework unless you want extra credit. Oh, we all perked up. Okay. Okay, so if you go back and put the line y equals x on your graphs for these, then you can get extra credit. Do you all see how those are symmetrical about that line?
Because they all meet in the same place.
They meet, yeah, so they meet right here, exactly. Exactly. Okay, questions on this?
Wait, how did you get the orange line?
Okay.
Sorry. Or the red line?
The red, orange, so you start at 1 and 1/3. That's the first, the y-intercept. Slope is 1/3, so from there you go up 1 and right 3. Up 1, right 3, up 1, right 3. Other questions? All right. How many people want to do the last example?
We'll all do the last example if you sing.
Is it new or is it not new?
No, it's the same set of directions. You're just graphing that in the inverse. No? So then we all are experts on graphing, right?
Yeah.
All right. So you have an assignment here. You have a group test tomorrow as well. And all of this stuff will be on the group test and the test. So everybody write that down.